Okay, here we come to the IGCSE 2023 October and November Additional Mathematics Paper 1 Set 1. So the first question is about the graph of trigonometric ratio, and this time we have the cosine graph. So how about that? We draw the original cosine graph and then compare with the new graph we have here. So for the cosine graph, it starts with 9 days and then end at 360 degrees, and also we can draw a little bit more for the negative values of x. All right, so here is the y is equal to cosine x. All right, this is the original function for the cosine graph. All right, so now we need to think about how this original function can change into the new function it is shown here. So we need to think about the values of a, b, and c, or what will they affect the graph. So here, for the first one, I always think about the period, or where it is here, or the value of b will affect the period of the function of a trigonometric function graph. So here, how can we get the period? Okay, we have two ways. First of all, you can think about the maximum to the maximum. How many degrees does it take? So for the original thing, it's from the maximum to another maximum. It takes like 360 degrees. So the original period should be 360 degrees. But now for this new graph, we don't have the two maximums, right? So we can also do the other way one, which is using the minimum. All right. Actually, between these two minimum, we can also find the period. So you can see that the period for the new graph should be 540 degrees minus negative 540 degrees. So which is 1080 degrees. But the original one is 360 degrees, right? So you can see that it is like triple, or you can just using the division of 1080 degrees divided by 360 degrees, it should be like 3. So we know that the period is like 3 times. So we get the value of b, because b will affect the period. So period here for the b should be 3 times. So b must be 3. All right. And then next we think about the amplitude, which is the value of a. Well, this value of a will affect the amplitude of the graph. So what is the amplitude? The amplitude is meaning the maximum value of y minus the minimum value of y. So for the original one, the maximum is like positive 1, and then the minimum of the graph will be negative 1, right? So the original amplitude right here, original amplitude should be 1 minus negative 1, which is 2, right? It's easy. So how about for the new graph? All right, the new graph, the maximum, it should be negative 1, the y. All right. So for the new amplitude here, it should be negative 1 minus the new minimum should be negative 9, right? So minus negative 9, we get a plus 8, right? Well, so amplitude must be positive, so it should be a 8. So you can see that the amplitude is changing from 2 to 8. All right, so think about the multiples, it should be 9 times 4, right? All right, it's 4 times the original amplitude. So now we get the value of a. All right, the amplitude, which is 4 times, so a must be 4. All right, so here's the most difficult part, which is the value of c. Actually, this value, we are doing a transformation, which is a translation of the graph. So we know about translation. If it's like positive, it will going upward. It will go upwards, and then for negative thing, it will go downward, right? Let's think about that. For the original graph, or just after the a and b, the maximum point should be 4, right? Because when we times 4, or the original maximum should be positive 4 and negative 4, right? But then the original maximum should be positive 4, and then the original minimum should be negative 4. But then here it comes to negative 1 for the new maximum, and then for the new minimum it comes to negative 9. So we can compare this and then see that, oh, this graph is actually going downwards compared with the 4 times cosine x over 3. All right. So here we can compare this and then calculate that for the maximum is from 4 to negative 4. So it's moving downward for 5 units. Or if we compare the maximum, or we can compare the minimum, we can also get the same answer, which is like the original is negative 4 minus new minimum value of y is negative 9. So it should be still positive 5 units. So, but remember, here it's going downward from positive 4 to negative 1, or from negative 4 to negative 9. So it's going downward, so the value of c must be a negative and negative 5. So here are the answers for question number 1. Question number 2 is obviously it's about the polynomial and the factor theorem and the remainder theorem, but not just that. This one we need to have some differentiation because of the last sentence. But first thing first, let's take a look on the very first critical sentence, which is p of x is divisible by x. So here the divisor is just x. So first we need to think about which value we need to substitute for the x. So here the divisor is x, so x should be 0. So just x is 0. We substitute that x is 0 into the p of x, and then we get the remainder, but this time the remainder should be 0 because we are using the word divisible. Divisible means the remainder is 0. So it's just that when we substitute x is equal to 0, we get the remainder 0. So the first one we get p of x, p of 0, will get you 0. So a times 0 to the power 3, and then minus 11 times 0 to the power 2, and then plus b times 0 plus c will be 0. And obviously, the front part will disappear. So we got c must be 0. And next, we come to the next sentence. The remainder of 3 over 2 when it is divided by 2x plus 1. So again, for the divisor here, 2x plus 1, we need to set it to be 0. So what should be the value we need to substitute? It should be 2x, which should be negative 1. So x should be negative 1 over 2. Okay, so now this time we substitute negative 1 over 2 into the p of x. And what will we get for the remainder? The remainder will be 3 over 2. So it will give you 3 over 2. And then we just do it. A times the negative 1 over 2 to the power 3, and then minus 11 times negative 1 over 2 to the power 2, and then plus b times negative 1 over 2, and then plus c. Oh, c is 0. Remember, we have already got that. All right, so it will be equal to the remainder. The remainder is 3 over 2. All right, so just simplify this one. We got negative a over 8, and then minus 11 over 4, and then minus b over 2 will be 3 over 2. So how about that? We can multiply all the thing by x, right? So just multiply it by x. We got negative a minus 22, and then minus 4b will be equals to 12, right? Yeah. So we got negative a minus 4b will be 12 plus 22 will be 34. Or we can write it like positive a plus 4b will be negative 34. Oh my god, we got 2 unknowns in one equation, so it's not enough. We must have another equation. So it comes to the last sentence, the green part about the differentiation. So obviously we need to differentiate p of x first. So just do it. P of x differentiate 1 times, we get 3ax to the power 2, because the power 3 will becomes the coefficient, and then the degree will decrease by 1. And the minus, again, the power 2 to the coefficient times 11 will be negative 22, and then x to the power just 1. And then plus this term for the x, it disappear, and then it just got b. But for the c, because it's just the coefficient, it's just a constant without x, so when we differentiate that one, we got 0, and it just disappear. So this is the differentiation of p of x. And then we substitute this one, the x is equal to 2 into this one, and then we got the whole thing. So 3a times 2 to the power 2 minus 22 times 2 plus b will be equal to 18. So we got 12a minus 44 plus b will be 18. So we got 12a plus b will be, how many is it? It should be 62, right? Yeah. So here we got two equations with two unknowns, so we just combine these two. And for the second equation, I will write it as multiply all the thing by 4. So here we got 48a plus 4b is equal to 248. This is the second equation. So now we can just deduct two equations. So for equation 2 minus equation 1, we got 47a, or 4b minus 4b, it disappears. So then we got 248 minus negative 34. So we got 74a, 47a will be equals to 282, and then divided by 47, we got a must be 0. Good, it's an integer. So I think we are correct. So how about b? So we substitute the value of a into either equation. So here I substitute into the first equation. We got 6 plus 4b will be equals to negative 34. So 4b must be negative 40. So b should be negative 10. So good, we got all the values of a, b, and c, where a is 6, b is negative 10, where c is just 0. So this is for the part A. Previously, we just got the values of a, b, and c in part A, where a is 6, b is negative 10, and c is 0. So we need to use this. So just write this down. So p of x should be 6x cubed minus 11x squared, and then minus 10x plus c. C is 0, so just that's it. And then we need to write this as a product of three linear factors, which means we need to divide this p of x by some factor. But the very first one is just given by the question, which is x. Or it must be divisible by x. So we just factorize this out. So we take out the x, and then we got 6x squared minus 11x and minus 10. So here we need to further factorize, because we just got two factors, and the first one is x, and then the second one is the whole bracket, but that one is not a linear factor, so we need to further factorize that one. So we can use what we have learned before in some junior form, which is the cross method. And here should be for 6, so we think about 3x times 2x maybe. And then for negative 10, it should be a positive times negative. So maybe we get 5 times 2, and then one should be positive, one should be negative. And here, how about we get 5, 2, 5, 2. Yeah, should be here 5 and here 2. So because the ultimate goal, we need to have negative 11. So it should be the negative 5 and then positive 2 here. So just try it. It should be like multiply it will get negative 15x, and then multiply that is positive 4x. So add them up with negative 11x. Yeah, so it is correct. So we got that it should be x times bracket. Remember, when we finish the cross method, the factor should be written down horizontally. So it should be like 3x plus 2 and 2x minus 5. That's it. All right, so actually the three linear factors should be x, and then 3x plus 2, and then 2x minus 5. And this is the p of x, yeah, as a product of 3 linear factors. That's it. Thank you. Question number 3. So obviously this question is about factor, but this is not a very difficult one. You can just draw point A and point B on the coordinate plane. So for point A, x should be positive 2 and the y should be negative 6. It should be somewhere like here. This is A. Okay, and then we draw B. B should be, for the x is negative 3 and the y is positive 6. It should be somewhere like here, maybe. Or just roughly draw it. Okay, so this is very important. Right? This term is finding the displacement of B from A. Alright, so we need to start from A and then think about it, how it can become B. Alright, so what's the movement or the translation? So think about the x first. For the x, is for A to B is moving leftward. Remember, for leftward, we should be having some negative values. So what's the unit? Alright, we can think about it. It should be like, for x is from 2 to negative 3. So the number of units should be 5 units. This is for x. So how about for the y? Let's think about the y. So y here is going upward. From A to B is going upwards. So the unit, it should be from the distance between this, it should be 6 minus negative 6, which is positive 2 units. Right. So here we got, for the part A, the displacement of B from A, which is actually just AB, this factor. Alright, this one should be, for the x is negative because of it's moving leftward, negative 5, and for y it should be moving upward, so it should be positive 12. So this is for part A. How about part B? It's asking about the distance AB. Oh, think about that. For distance, actually, it's just this value. So we can use the Pythagoras theorem, and then we know that AB should be 5 square plus 12 square, and then all square root. So obviously it's 13, or you can use your calculator to check it. So it should be 13 units. So this is for part A and part B. All right, so now we come to part C. So for part C, we have one more information, which is 3 times the factor AB will be equal to 2 times the factor AX. So what does this mean? All right, we can just imagine that for AB, all right, this is the factor AB, and then this factor multiplied by 3 times, like this, will be equal to 2 times AX. All right, so it should be something like this. The purple one is AX. All right, we just need 2AX. We can make 3AB. So from this equation, we know that the direction of AB should be just the same as the direction of AX. So AB should be somewhere here. So X should be somewhere here, a little bit longer than AB. X should be somewhere here. So this is the image. But what do we need to do now? All right. First of all, this question is asking about the position factor of X, which is OX, this factor. So we just started from the equation we got, right, which is the 3AB is equal to 2AX. And then we need to break down the AX so that we can obtain the factor OX. So what do we get? We just add O in between A and X, which is 3 times AB will be equal to 2 times bracket AO plus OX. And then we just break the bracket. We got this. 3 times AB will be equal to 2 times AO and plus 2 times OX. But we don't know the value of AO, right? We already know that is for OA, the unit factor of A, the position factor of A. So we can change AO into negative OA. So we got here, okay? And then we can just substitute the value of AB and OA factors. because these two factor is already given, is already calculated or given. So for AB, it is -5 and then 12 from part A, and then for OA is just 2 and -6, and then we can just break the factor or multiply the 3 and 2, -2 into the factor. So we got here -15, 36 will be equal to -4, 12 plus 2OX. And then for the factor, we can just minus the red one to the left-hand side. So we got something like here. All right, so after some calculation, we can make it into this. All right. But for the right-hand side, it's still 2 times OX factor. We want OX factor only. So we need to divide all the things, X and Y, by 2. So we got something, OX will be equal to -11 over 2, and Y should be 12. And this is the position factor of X. And that's it. Thank you. Question number 4. So obviously this question is about maybe logarithm, but also is mainly about the straight line graphs first, because we need to draw some straight line graph. But this one is about the natural log x against the natural log, natural log y against natural log x. So in the terms of natural log, it means the base we are using is e instead of the normal logarithm, which is base 10. So when we use our calculator, you need to be careful about that. So first thing first, if we are not just pointing out the xy, we need to use the natural log x and natural log y. So how about the natural log x first? Use your calculator and then calculate every natural log x. So for natural log 1, remember, you need to press ln instead of log, because log is meaning the base 10, but ln is just base e. So natural log 1, you have 0. And because of the x-axis, the natural log x-axis is from 0 to 0.2. So the smallest unit will be 0.05. So I will have maybe 2 decimal places for the natural log x here. So the next one, natural log 2 will give you 0.69. Natural log 3 will give you 1.10. And then natural log 4 will give you 1.39. And then natural log 5 will give you 1.61. Yep, so that's for natural log x. How about natural log y? Use your calculator again. Natural log 20 will give you 3.0. So for natural log y, we can take a look. It's from 0 to 1. So the smallest one should be 0.2. So I will just have 1 decimal place for natural log y. So, and the next one, natural log 57 will give you 4.0. Natural log 104 will give you 4.6. And natural log 160 will give you 5.1. And then natural log 224 will give you 5.4. So that's all. So now we need to mark all the points in the graph. So the first one should be 1 natural log x is 0. Natural log y should be 3. So we'll give you this point, the very first point. And the next point, 0.69, which is near 0.7. And then 4.0 should be here. And then 1.1 and 4.6. 1.1 and 4.6 should be somewhere here. And the next one, 1.39 and then 5.1. Maybe I will just use 1.4. And 5.1 should be somewhere here. And then the last one, 1.61 and then 5.4. I just use 1.6. And then when it is 1.6, 5.4 should be here. So if you got all the points correct, you should get a straight line or straight or similar to a straight line. But if you got maybe one point is very far from the straight line, maybe that point is incorrect and you need to recalculate it using your calculator. So here I get my straight line correct. So I just draw a straight line passing through all the points. So this is for part A. How about part B here? Oh, this time we need to find the values for the A and B. But we haven't got an equation about natural log x and natural log y, so we need to make the original equation y is equal to ax to the power b, or in terms of natural log y and natural log x. But how to do it? Just take natural log on both hands first. So we got natural log y is equal to natural log a times x to the power b. But we know that for the properties of logarithm, we can just separate it for the right hand side. And because it's a times between a and x to the power b, so we can have natural log a plus natural log x to the power b. So how about for the power b, or for the index, we can make it into a coefficient. So we will get natural log y will be natural log a plus b times natural log x. See, the index becomes the coefficient. So now if we compare this with our graph, how about we call the natural log y to be a capital letter Y, and then for the natural log x is the capital letter X. So we compare this with our equation. It's just y is equal to natural log a plus b times natural log x, which is, if we rearrange it, it should be like bx plus natural log a. So if we compare with the y is equal to mx plus c, right, the b is actually the gradient, while the natural log should be the y-intercept. So we can make use of our graph or your graph. So for my graph, the y-intercept of this point should be here, 3. So we can get that natural log a must be equal to the y-intercept, which is 3. So according to the definition of natural logarithm, a should be equal to e to the power 3. And then we can use your calculator again. And remember, this time we need to give our answers correct to 2 significant figures. All right. So here a we will get 20. All right. So how about b? I just said that it is the gradient, or the m, right? So for the gradient of this graph, maybe we can just use 2 points. We can just use the y-intercept point and also this point. So for my b will be equals to 4.0 minus 3.0, the difference for the y, and then divided by 0.69 minus 0. So I will get like this number. B should be equal to 1.45 for my B. Maybe you got a slightly different B, but it's okay. So this is the value for capital A and then small b. Okay, so now we come to part C. This time we need to estimate the value of y when x is equal to 3.5. But remember, we must use the graph. It's very important. So here, if we want to use our graph, we cannot use just x. Right? We need to use natural log x for the graph. So here we first find the value of natural log 3.5. Just substitute x into it, and we got 1.25. So we can just find the value of natural log 3.5, what we will give for the natural log y. So here we find the 1.25. 1.25 should be somewhere here, and then we draw a vertical line upward until we meet the graph. So I meet my graph here. Once they meet, and then we can draw a horizontal line toward the left. So for me, I will get 4.8 for the natural log y. So I will get natural log y must be 4.8. So, but we want to find the value of y. So based on the definition of natural log, y should be e to the power 4.8. So we got it using our calculator. I will get 122. That's the answer. But yours may be a little bit different from me because of the graph, or maybe slightly different from it. All right, but that's it for question number 4. question number 5. So obviously this one is talking about the permutation and combination. So for part A, the whole thing is about some code, so it must be permutation because the position doesn't matter. So for part B, it's about picking someone to a group, so it's just the combination, or maybe we can just use NCR to finish that. So but let's focus on part A first. So this term, how many digits we need to form is a 4-digit code. Oh, by the way, actually you can use NPR for this kind of question, but for me, I always think about using some blank. Alright, so for 4-digit code, it will be like 4 numbers we need to find it. Alright, so think about that. We have from 0 to 9, how many digits are there? Not 9, because from 1 to 9 there are already 9 digits. So adding the 0, actually we got 10 digits, 10 possibility we can get for each blank. Alright, but no one can be used more than once, so it cannot be repeated. And then for the first code, it can be start with 0. So we just think about the first one. So for the first one, we have 10 digits we can use, so just put a 10 here. So for the next one, as long as the first one we have used any one number out of this 10, we can just leave you 9 possibilities, right? So followed by that, the third one we just got 8 only, and the last one we got 7. So we just use the calculator and then we can have the answer 5040. Or you can just use P, which is just equal to 10P4, if you understand that. Alright, so that's for part 1. How about part 2? For part 2, it must be an odd number. So again, for the 4 numbers here, 4 blanks, this time because of the odd number, we need to think about the last digit. So for odd number, we can have 1, 3, 5, 7, 9. That's or 5 digits can be put in here. So there should be a 5. This 5 is meaning 1, 3, 5, 7, or 9, or either of them, or just pick one. But as long as we pick one, we will just have 9 digits left. So we come back to the first one, it must be 9. And then for the next one, we have used one more, so we leave you 8, and then followed by 7. Alright, so just use your calculator and then you will give 2520. If you know P, or you can also use it, or you need to consider the odd number, which is 5P1 times all the other numbers. So you got 9P3. It's just the same, or you can also use this. And then for the last one, it's a little bit tricky because this time we need to form a number greater than 1000. Oh my god, for greater than 1000, we can have start with 1, then 2, blah, 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 and then 3, and then until 9. Actually, you can think about that and then add them all up, you can have it. But we can also do it the other way around. What is the code that we don't want? Actually, it should be something less than 1000. So think about that. For the less than 1000, what should be the possibilities? Right? For less than 1000, it means the first one must be 0. Right? So we just have one digit. This one is meaning the 0. And then once we put the first one as 0, the remaining thing we got 9 digits because the 0 has been used. So it's 9 and then followed by 8 and 7, which is 504. And for this one, you can also calculate by 1P1, which means 0, and then put it in the first digit, and then times 9P3. It's still the same, and then you can get the 504. But that's not the end. We need to think what are the things that are greater than 1000. So for less than 1000 is 504. So we can just make use of part 1. All the possibilities are 5040. So greater than 1000 should be right here, 5040 minus 504, which is 4536. That's for part A. So now we talk about part B. So this one is obviously about the combination because we are picking some people to make a team. So how many people we got? All right. Originally we have 15. All right. And out of this 15, there's a family of 4 people who must not be separate. All right. They are linking to each other. And then we need to pick 9 out. All right. So think about it. Actually, there are 2 situations. The first situation should be easy, and you should be able to think about that. We just pick the family. So out of this 9, we just pick all the 4 people. So here, if we use the NCR, it should be like 4C. Right here, 4C4. Out of these 4, we just use all that 4 people. But how many positions left? It should be 9 minus 4, which is 5, right? But how many people can we choose to fit in these 5 positions? It should be like 15 minus 4 because 4 family have already chosen. So this one is actually 11 C5. So that's the first situation, and then we just use calculator. You get like 462. That's the first situation. The next situation is that we don't want the family. Sorry, this family has to be disappear in the team. I will write in the left hand corner here. So for those 9 members, we got all of them from those who are not the family, which is 11 possibility. So here it is 11 C9. And using your calculator, you will get 55. And these 2 situations are both possible. So the final outcome should be like 462 plus 55, and it will give you 512. That's a little bit tricky because of the last part or the front part, or maybe you will just ignore one, but actually both can be possible. So this is for question number 5. Question number 6. So this time is about logarithm. So how about we take a very quick look on the properties for logarithm. So remember, for any indices, we can just make it into coefficient, but also we can make the coefficient become the index. And then for 2 not, with a plus in between them, then we can make it into 1 not with just multiplication. And then for 2 not in between them with minus, we can make it into 1 not with a division. So this one we need to combine all the thing into just one logarithm to base 10. So what do we do first? Is about the index. Make the coefficient into the index first. So here for 3 and 1/2, it needs to become the indexes. So the first one, you get log x to the power 3 and then minus log 4 to the power 1/2. So how about for the plus 2? It's not a log with base 10, so we need to make it into a log. So it should be like log base 10 to the power 2. So here how we change into a logarithm using the definition. And then next, how about we simplify this first? Log x to the power 3 and then minus log 4 to the 1/2 is to be 2. And then plus log 10 to the power 2 is 100. And then for this minus and plus, we can make it into a division and multiplication into 1 log. These 3 log all together into 1 log. So it should be log x to the power 3 divided by 2, and then this add will be multiplied by 1000. And then we need to simplify this and finish. So it should be like log base 10 it's log 1000. It should be 100. Oh, I'm too excited. So it should be like 50x to the power 3. So that's it with one single logarithm to base 10. That's part A. So now we comes to part B about an equation. Okay, but this time, these two knot is having two different bases. So maybe we need to think about the changing base property I just written down here. So first thing, so how about we change it a little bit? Or maybe let x to be log 4a. I will use log 4a instead of log a4 because I think when later on we need to change it to get the value of a, it will be easier. So when not 4a is equal to x. So how about log a4? Let's think about log a4 using the changing base property. Log a4 is actually equal to log 4 over log a, right? So log 4 over log a, we can think about it just equal to 1 divided by log a over log 4. I just swap them. So log a over log 4 actually is just log 4a. So we can make it into 1 over divided by log 4a. Or we can write it this way, 1 over log 4a. So log 4a is just x. So we can make it, or for a log a4, it's just equal to 1 over x. If x is log 4a. Okay, then we can do it. So this one, this equation will be changed into 2 times 1 over x minus 3 times x, and then minus 5 is equal to 0. Oh, that's just a quadratic equation, and it will be easy. So then multiply all the thing by x, you got 2 minus 3x squared minus 5x is equal to 0 times x is still 0. So rearrange them, it becomes 3x squared plus 5x minus 2 is equal to 0. I just multiply -1 to all the terms. So here you can use cross method and 3xx, or you use the formula is still okay. 1 over 2, and then there's a plus and minus. So yeah, that's it. So we will get 3x minus 1 and x plus 2. It should be equal to 0. So x should be equal to 1 over 3, or x should be equal to -2 plus the n. All right, because we need to find the value of a. So x is equal to 1 over 3. We just substitute back here. It should be log 4a is 1 over 3. So similarly, we have log 4a is -2. So what is the value of a then? A should be 4 to the power 1 over 3, or using the definition, or the base to the power. Or a can be 4 to the power -2, or for 4 to the power 1 over 3, that's the n, that's the exact form. But 4 to the power -2, we need to make it into 1 over 16. Yeah, you can use your calculator or just using the index thing. So that's it. Or a can be 2 possibilities. We should also check the value. Or a is here, or in the equation, is maybe the base or maybe inside the log. So a must be positive. So check again. 4 to the power 1 over 3 is positive, it's okay. And then 1 over 16 is still positive. So both answers are correct. So we just get the final answer to be 4 to the power 1 over 3 or 1 over 16. So that's for question number 6. Question number 7. So this time is about the differentiation. So we need to differentiate it. But before that, let's take a look on the function f of x. Here, it's made of 2 products, the red one and the blue one. So maybe we need to think about the product rule I just write here. All right. But some students may think that, oh, can we just break down the function f of x and then further differentiate it? Actually, we can do it that way, but let's take a look on here. The f prime of x, the question asks us to write it in the form of 2 times 3x minus 2 and then times another bracket. So we need to do some factorization. So I would suggest you to just use the product rule. So let's do it. For the red one, if we differentiate 2x plus 1, it will just give you 2, right? How about the blue one? The blue one here is 3x minus 2 to the power 2. So we need to use the chain rule first. So it will be equal to 2 times 3x minus 2, and then further differentiate the bracket. It will be 3. This is the derivative of the blue one. So now we can differentiate f of x. All right, for this f prime of x, using the product rule, it will be equal to the red one times the derivative of the blue one, which is 2 times 3x minus 2 times 3, and then plus the blue one. The blue function is this one, 3x minus 2 to the power 2, and then times the derivative of the red function, which is just 2. So this is for the step 1. And then remember, we need to factorize out the 2 and the 3x minus 2, these two factors. So consider these two to be taken out. The front one will give you 3 times 2x plus 1, and the later part will give you just 3x minus 2. So we need to simplify this one, or for the whole bracket, you give something like this, 6x plus 3, and then plus 3x minus 2, and then further simplify it, you will have the answer. F prime of x is actually 2 times 3x minus 2, and then times 9x plus 1. Or compare with this, p is actually 9, and then q will be positive 1. So this is for part A. So we come to part B. We need to find the coordinates of the stationary points on the curve. So here, just the stationary points. We need not to find if it is maximum or minimum. So for stationary point, the f prime of x must be equal to 0. So we just get f prime of x from part A. So just substitute it in, the whole thing will be equal to 0. And then we know that is a quadratic equation. Each factor should be equal to 0. So it will give you 3x minus 2 should be equal to 0. And this will give you x must be 2 over 3. Another answer for the x should be 9x plus 1 will be equal to 0. And the x should be negative 1 over 9. But remember, this time we need to find the coordinates. So we need to also find not just x, but also y. And here we need to substitute the x, these two x values, into f of x again. Remember, not f prime of x, but f of x to find the original point. So here, for the first one, if we substitute 2 over x into x, it will give you, just 0. You just use your calculator to do this. And then how about the next one? If you substitute negative 1 over 9 into the f of x, it will give you 343 divided by 81, or just some decimal numbers is still okay. But remember, we need to write down the coordinates. So there are just 2 stationary points, which are, the first one is when x is 2 over 3, the y should be 0. And the other one will be when x is negative 1 over 9, and then the y should be 343 divided by 81. And this is for part B. So now we come to part C. This time we need to sketch the graph of y is equal to f of x, and then indicating the intercept of the coordinate axis. So how about we just find the intercepts first? For the y-intercept, we need to substitute that x to be 0, and then using our calculator, y should be equal to 4. So let's mark this down on the plane. So it should be somewhere like here, right? X is 0, y is 4. Okay, and the next, for the x-intercept, we need to substitute that y to be 0. So this one is already factorized. So we know that 2x plus 1 must be 0, or 3x minus 2 must be 0. So it will give you 2 value of x, which is negative 1 over 2 and the 2 over 3. So just write these 2 points. It should be somewhere here. And then the later one should be negative 1 over 2. And then 0. So we got 3 points, but we also have 2 points in part B, which is 2 over 3 and 0. It's just the same as one of the x-intercept. All right, but we need to check if it is maximum or minimum later. And then another one is the green one from part B. Here we need to compare it with the y-intercept 4. So for 343 divided by 81 using the calculator, it is something like 4.23. So this green point should be a little bit higher than the blue one. So I will write here. For this green one should be -1/9 and then comma 343 divided by 81. So we have got 4 points here. But okay, we need to check these two stationary points, the purple one and the green one, if they are maximum or minimum. So how do we find it? We need to differentiate f prime of x again. I differentiate it using the product rule and then simplify the bracket, and then further simplify it, you will have something like this. All right. So the second derivative of f of x should be 2 times the bracket 54x minus 15. So now we can substitute the value of x into the second derivative to check if it is a maximum point or minimum point. For the purple one, x is 2/3, so we just substitute it inside, and it is a positive value, which is 42. It is larger than 0, so this point must be a minimum point. So I will draw something here. We should see something like this for the purple one. This one. And then how about the green point? All right, we substitute -1/9 into the second derivative, and then you will get something negative, or -18. Just use your calculator. So this one must be a maximum point. All right, so this one, we should see something like this. So now we can just link it together. The whole thing should be like this. Alright, because of the minimum and the maximum. So this is the graph for the y is equal to f of x. And this is for part C. So now we come to part D. Alright, here we need to find the values of k, such that the equation f of x is equal to k has 3 distinct solutions. So what does that mean? We have already got one black curve, which is y is equal to f of x. So just imagine we have one more line, where this line is y is equal to k. And y is equal to k, it must be a horizontal line. So imagine this horizontal line, we move it upwards. Alright. When f of x is equal to k has solution, it means this black curve and the purple line will have intersecting point. Or just like here, we have one intersecting point, meaning for this value k, we'll have just one solution only. So when it comes to here, meeting these two red points, you will have two distinct solutions for f of x is equal to k. And then later on here, you will have f of x is equal to k having 3 distinct solutions. But when does it end? When the k is going up again until it meets the green point, it will be having 2 distinct solutions, and then later on it becomes 1 again. So the range of k should be in between this and this. So we need to think about this range. K should be in between these 2 values. So for the upper one, this one should be 343 divided by 81, and the lower one should be 0. So the value of k is actually in between 0 and 343 over 81. Remember, we cannot have equal sign here, because when it is equal, when k is equal to 0, it has just 2 distinct solutions, but not 3. So this should be the values of k. And this is for question number 7. Question number 8. This time, this question is about simultaneous equations. So let's see what we have got here. First of all, we have a red line. This straight line is meeting the curve the blue one, which is a quadratic function, at 2 points, the point A and point B. And then there is a tangent to the curve at B, which is this green one. And this green line is meeting the horizontal line through A at point C. So we need to find the x-coordinate of point C here. So there's plenty of things we need to find out. First of all, we need to find out the coordinates of point A and point B. Then we need to find the gradient of this green line. And then furthermore, we can find the equation of this green line. After all, we have simultaneous equation with this purple one and this green one. We can find the coordinate of C. So let's begin with the 2 points, point A and point B first. Consider them simultaneously. Substituting 1 into 2, we can have a quadratic equation. So we need to make the right hand side to be 0, meaning moving all the terms to the left hand side. And then simplify this, we get this. Next, we can divide all the terms by 2. And now we can have cross method, or we can use the quadratic formula to find the values of x. And here I use the cross method. So we have x should be 3 over 2, or x can be -1. But remember, we need to find the coordinates of A and B. So we need to find the values of y. So here we need to substitute it back into equation 1 or equation 2, but I choose equation 2, which is easier. So here, when x is 3 over 2, y must be -5, while when x is -1, y must be +5. But here's a question. Which one is point A and which one is point B? Point A is in the quadrant 2, so the x must be negative and the y must be positive, while for point B, the x must be positive and the y must be negative. So point A must be the right point, while the point B must be this point. A must be -1, 5. B must be 3 over 2, -5. And that's for point A and point B. So now we need to find the equation of this green line, which is a tangent. But how to do it? We should find the gradient of this one. We can just differentiate the blue one, and then it will give us 2 times 4x and then minus 6. Simplify it, we got 8x minus 6. And then, because we want to find the gradient at point B, so we need to substitute the value, the x-coordinate of point B into this derivative. Gradient of the curve at B should be 6. So now we can make use of y is equal to mx plus c, but here I will use mx plus k because there is already a c, so I will try to use another variable which is k, where the m, the gradient is 6, and then the k is the value we need to find out. So how to find this? We can just substitute the point B into it. The x should be 3 over 2 and the y should be -5. By solving this, we can get the value of k, which should be -14. So the equation of this green line should be y is equal to 6x minus 14. So now we come to the ending. We need to find the x-coordinate of C by using the simultaneous equation of this purple line and the green line. For the green line, we have already got it, but how about the purple one? This one should be y is equal to the y-coordinate of A, which is 5. Solving simultaneous equations, we can have the value of x. This is the x-coordinate of C, whereas the y-coordinate of C should be 5. Remember here, we need to give our answer correct to 2 decimal places. So the final answer should be 3.17. And that's for question 8. Number 9. So this time is about series, that topic. So for part A, we have an arithmetic progression, AP. So how about that? We call some formula about AP, which is the common difference D should be AN plus 1 minus AN. So maybe we can use A2 minus A1 or A3 minus A2. And then for the nth term, it is equal to A, which is the first term, plus bracket n minus 1 times the common difference. So now let's see what we have got. For the first 3 terms, they are negative 3 tangent theta over 2, negative tangent theta over 2, and tangent theta over 2. We also have the 12th term. It is equal to 19 square root 3 over 3. We need to find the value of theta. So now let's just identify something. How about A? The first term must be negative 3 tangent theta over 2. How about common difference D? I use A2 minus A1 here. So A2 minus A1, I will have this. Simplify it, I will get positive 2 tangent theta over 2. And then we can make use of this for the nth term using this formula. I will have for the 12th term, it will be the A, the red one, plus n minus 2, where n is 12, times the blue one, which is the common difference. But for this number, it is just equal to 19 square root 3 over 3, so we can just substitute it inside. And then for the right hand side, just simplify it. And for negative 3 plus 22, we have 19 tangent theta over 2 on the right hand side, and then divide 19 to the left hand side, we will have this equation. And now maybe you can use your memory. Actually, tangent 30 degrees must be equal to this, or square root 3 over 3. But if you forget it in the exam, maybe you can also use your calculator to press shift tangent square root 3 over 3, and you will have the answer 30 degrees. But we want to have radiant units, so you need to change it back into pi over 6. So here I will have these 2 values. Oh, why 2 values? Positive tangent, I will also think about the quadrant 3, which is pi plus pi over 6. If you are not sure if it is correct or not, just write it down first and then simplify these 2. But for the final answer, you need to check. The theta is pi over 3, one answer. And the other one, if you simplify it, you will have 7 pi over 3. But 7 pi over 3 should be larger than pi over 2, so it is rejected. So we just got one value of theta, which is theta over 3. Now we come to part A2 of this AP. We need to find the exact value of the sum to 10 terms of this progression. So let's recall some formula. We need to use this sum to n terms, which is 1 over 2 times n times bracket a plus l, whereas l is the last term. And in part 1, we already know that theta must be pi over 3, and a should be negative 3 times tangent pi over 6, while d, the common difference, is 2 times tangent pi over 6. So now we can make use of this to find first the 10 terms. It is equal to the a plus bracket 10 minus 1 times the common difference, and then simplify this, we will have something like this. So negative 3 plus 18, we will have the 10th term should be 15 tangent pi over 6. And now we can make use of the sum to nth terms. Just substitute all the thing, right? Whereas n is 10, and then the first term, and then the last term, 15 tangent pi over 6. Add them up, you get 12 tangent pi over 6. For 5 times 12, you get 60. Or tangent pi over 6, it is equal to square root 3 over 3. Remember, we need to use the exact value, but not using the calculator. So here, just simplify them. You will have 20 square root 3. That's it for part 2. Now we come to part B. we need to find something about a geometric progression, GP. So let's recall some formula about them. For a common ratio, it is equal to an plus 1 divided by an. For example, a2 divided by a1 or a3 divided by a2. And then for the nth term of a GP, it is equal to a, the first term, times the common ratio r to the power n minus 1. Remember, it's n minus 1 power, but not just n. This GP is made of the first one, 1 over 16, cosecant phi to the power 4, and then 1 over 4 cosecant phi to the power 2, and then the third term 1, which is a good number, just an integer. And then we also know that for the sum of the third term and the fourth terms, just 2 terms, is equal to 4. We need to find the possible values of phi. So maybe we have more than one values of phi. So let's begin with identifying a and r first. So for a is just the first one, but I will here make it into from cosecant to sine, because later on maybe we need to solve some trigonometric equation. So I will make use of sine instead of cosecant. So it will be 1 over secant phi to the power 4. So how about the common ratio? For the common ratio, I will use the third one divided by the second one, will be here, 1 divided by this whole thing. And similarly, I will make this into sine, which is 1 over sine phi to the power 2. And for these two fractions, or multiply them, it's just 1 over 4 sine square phi. And then for 1 divided by this fraction, it will just give you 4 sine square phi. So now we have a and r. So how about the third term and the fourth term? Oh, come on. The third term is just 1. So just write 1. So how about the fourth term? It should be the third term times the r common ratio, because the common ratio is 4 sine square phi. So the fourth term is just 4 sine square phi. So now we can add these two up. They will be equal to 4. So we have one trigonometric equation. So just solve this one. So minus 1, you got 3 in the right hand side, and then divided by 4. Remember, it's a quadratic one, so we should have two values of sine phi. So for sine phi, it can be positive square root 3 over 2 or negative square root 3 over 2. So for positive square root 3 over 2, if you remember it, actually it's just equal to 60 degrees. But if you don't remember, you can just press calculator and you'll get 60 degrees. But again, we need to make it into radian units. For the red one, you have two values, which is pi over 3, which is 60 degrees, or we can also think of the quadrant 2, which is pi minus pi over 3, which is 2 pi over 3. But here for 2 pi over 3, it is larger than pi over 2, so it is rejected. So how about for the blue one? For negative square root 3 over 2, you should get it negative 60 degrees with your calculator. So it's just negative pi over 3. And the other values should be the third quadrant, which is pi plus pi over 3. But this, again, is larger than the range here, pi over 2. So it is also rejected. So we just got only two values of phi, which is phi can be pi over 3 or negative pi over 3. Now for part B2, we need to determine whether or not this progression has a sum to infinity. So let's recall the formula of sum to infinity is a divided by 1 minus r. But very important, absolute values of r must be less than 1, which means r can be in between 0 to 1 or in between 0 to negative 1. So but what is the value of r here? We just find it and we can determine. So before we find this r, we need to make sure we know the values of phi, where we have done in part 1. It is pi over 3 or negative pi over 3. So we just substitute these two values. Remember, both of them should be substituted. So now we got r can be 4 sine square pi over 3 or 4 sine square negative pi over 3. So here, For sine pi over 3, it is equal to square root of 3 over 2, and all square, you will have 3 over 2. But for sine negative pi over 3, you will have negative square root of 3 over 2. But after squaring it, you still got 3 over 4. So anyway, you get the same value of r, which is 3. It must be 3 for either case. So r must be more than 1. Absolute value of r must be less than 1. So for both cases, we cannot have a sum to infinity here. That's it for question number 9. Number 10, the last question. So this question is about differentiation because of dy over dx. So let's see what functions do we need to differentiate. This function is quotients of functions. So maybe we need to use the quotient rule here. Differentiate u over v, where u and v are both functions of x. Then we can have the denominator v times the derivative of the numerator u, and minus the numerator times the derivative of the denominator, and then all the way divided by the denominator square. So first of all, we differentiate the numerator and the denominator separately. So for the numerator, first of all, I will make the square root into 1 over 2 index. Then we can just use the chain rule. This 1 over 2 will become the coefficient and multiply the bracket to the power 1 minus the original index, which is 1 minus 1 over 2. That gives you negative 1 over 2. And then remember, for the chain rule, multiply by differentiate the bracket, which is 6x. Because the final ones will be written in the form of this, so I will change this negative 1 over 2 index to the denominator. For negative 1 over 2, it becomes positive when it is in the denominator. And for 1 over 2, it becomes the square root again. And then for 6x times 1 over 2, you get 3x. So this is the derivative of the numerator. So now we differentiate the denominator x minus 4, which is easy. It's just 1. Now we can use the quotient rule. Using the quotient rule, the denominator times the derivative of the numerator minus the numerator, original one, times the derivative of the denominator, and then all the way divides by the original denominator to the power 2. How do we simplify this? For the numerator part, for the front part, you just multiply the x minus 4 and the 3x, and then you will have 3x times x minus 4. But for the later part of the denominator, because the front part we have a fraction and the denominator is square root this thing, so this one we need to use this formula to change it into a fraction. So for a square root a, we can multiply it by square root a over square root a, and for the numerator you will get just a, or cancel the square root, and it is just equal to a divided by square root a. So here, I will just multiply it by the square root of this thing divided by the square root of this thing. For the front part, 3x times x minus 4, you will have 3x squared minus 12x. For the later part, these two multiplied together, you just cancel out the square root, and it gives you the original one, 3x squared minus 2, but remember to add the bracket because of the negative before them. So these two denominators are the same now, then you can just make it into one fraction. And then after all, you divide it by the black square. Simplify then this, 3x squared minus 3x squared, you cancel out, and then negative 12x minus 2, which is plus 2. And then this whole thing divided by the x minus 4 squared, so this one can become the denominator. So let's compare with this. A is just negative 12, while B is 2. And that's it. Now we come to part B. Here we need to find, in terms of h, the approximate change in y when x increases from 3 to 3 plus h where h is very small. So we need to make use of one formula, which is that delta y over delta x is equal to dy over dx. So multiply the delta x to the right hand side, you got delta y is equal to dy over dx times delta x. So what does it mean by delta y? Delta y is the change in y, while delta x is the change in x. So what do we need to do? First, we need to find the dy over dx at the point 3, because it's increased from 3 to 3 plus x. So we need to substitute the x is equal to 3 into dy over dx. And then we need to find the change in x. So when x is 3, dy over dx will be that value. Using your calculator, it is equal to negative 6.8. Remember, the negative or positive is important. And then, how about the delta x, the change in x? So we can use 3 plus h minus 3. And it just gives you h. Delta y must be equal to negative 6.8 h. Remember, the answer is in terms of h. So we just finish it. This is the change in y. So that's for question number 10. We have just finished all the questions for IGCSE 2023 October and November. Additional Mathematics Paper 1, Set 1. Thank you.